And welcome in to part 2 for circle word problems by party people. Today we are moving forward and working on not just radius, diameter, circumference, and area. We're actually going to be introducing 2 more ideas here, and that is going to be sectors and arcs. So, just like yesterday, these are the same as the previous lesson's goals: understanding radius, diameter, circumference, and area. We'll review those briefly. And then from there, we'll really get to work on some keywords and word problems, just like we have been. But then the third thing that we're getting into today, again, we're working on sectors and arcs. So just as a reminder, a healthy reminder, we are going to be going over the pure definitions of these, but just as a quick little overview, arcs are basically fractions of a circumference. So fractions, when I say that, I just mean a part. So it could be half, it could be a third, could be a quarter, could be 2/3. Who knows? We'll talk about it as we go along. But all you need to know is that an arc is a fraction or a part, a piece of the circumference, and a sector is a piece of the area. So today, we're just taking the next step by talking about fractions of circumference and fractions of area. It might sound a little tough, especially if we're anxious about fractions themselves, but remember that the idea can still make sense even if we're not confident with those. So let's go ahead and remind ourselves of the notes from yesterday's class. And as always, if you have not had the chance to go through these pages of notes, here's one, here's page 2, and don't worry, I'll pause it for a moment here to give you a chance to write these down. But just know that if you are writing these notes down, here's the 3rd page, and you feel like, man, I should definitely refresh, I would recommend going back to that previous recording. And here's the last page right there for area before we get into these newer notes. So I'll pause right here for a moment to give you a chance to write all of these down, and then we'll get started with our examples. All right, so let's move forward here to our first example of a few coming up. So talk to me, everybody. If we are trying to find the diameter that we can clearly see listed as the instruction, what is the diameter when we're given the radius? Can anybody tell me in the chat box, when we have the radius, what do we do to get to the diameter? Again, let's suppose that the radius is right here, and that radius is 16. Again, from the center to the edge. That's right, everybody. If we're thinking about diameter, then we are thinking about doubling that radius, because diameter would be all the way across. Diameter is all the way across, so if you have 16 over here, it's 16 over there. 16 times 2, that is 32. Again, one more time, everybody. The radius is just from the center to the edge, or center to the edge, or center to the edge. The diameter is all the way through. So I could have drawn it here, I could have drawn it like that, I could have drawn it no matter what way, it doesn't matter. As long as you go through the center, you are good. And again, the 2 comes from the diameter being double the radius. Multiply the radius by 2, and that's where that 2 comes from. Our radius was 16, multiply that by 2, and that gives you 32. 2 times 16, right on there. My party people, before I continue, does that jog our memory on the relationship between diameter and radius? Sounds good. Now let's go ahead and give this next one a shot. So now we're given the diameter of a circle as 6, and we want to find the radius. Quick, my party people, what is that answer going to be? And more importantly, not just what the answer is, what do we do? What's the action that we're going to take to go from the radius, from the diameter to the radius? Yeah, we divide by 2. That's right. Remember, the radius is half of the diameter. So with that diameter being 6, we divide that by 2, and that gives us 3. And that right there, my party people, that is our radius. So again, if we're going to the diameter from the radius, you double it. If we're going back to the radius from the diameter, we cut it in half. So let's go ahead and move forward here to example number 3, where now we are starting off with the radius of a circle, and we want to find that circumference. One more time, the goal here is to find the circumference. Everybody How many formulas do we have for the circumference so far? Yeah, we've got 2 of them. Let's go ahead and write them down. The first one being circumference equals 2 pi r, and the other one is circumference equals pi times d. Now, everybody, just like I said before, and as a nice, gentle reminder, we want to choose the formula for which we have the information. So with that said, we are given the radius. The radius is represented by the letter r. So what that tells me, everybody, again, these formulas are the exact same, but given that this one uses the radius, I'll just go ahead and use this formula. So what I'll do is I'll say C equals 2 times pi times r. Everybody, my r, my radius is what again? Yeah, that's going to be 24, right on. Booyah. So then we have our 2 multiplied by 24, and that's going to give us 48. Now, in this problem, everybody, who can tell me if this is going to be 48 pi, or if I need to do 48 times 3.14? Which one is it going to be in this problem? Yeah, in this one, it's going to be just leaving pi as pi. And remember that all the information you need is going to be on the screen. We see that it says use pi as pi. So basically they're saying leave pi as is. And so when we take a look, this is the right way we want to go about it. So our correct answer here is 48 pi. And there we are. Just leave it like that. No need to get an exact answer. We are good. All right. So with that, again, we've gone over going from radius to diameter, diameter to radius, radius to circumference. Now let's see how we handle this one. So here we are given the diameter of a circle as 23.3, and we're trying to find that circumference. So let's go ahead and do that here. Circumference formulas are going to be C equals 2 pi r, and the other one's going to be C for circumference equals pi times d. In this situation, in this circumstance, which formulas should we be using? Option 2? Yeah, I agree with you wholeheartedly. This is going to be the right option to go with because this formula uses the diameter, and we are given the diameter. So remember, everybody, the big advantage you have with geometric formulas is that they're hyper-specific, and you'll be able to point out the pieces that you have or the pieces that you'll need. So with that said, circumference equals pi multiplied by that given diameter, 23.3. And then from there, pi times 23.3 is just written as 23.3 pi. And again, just like in the previous one, we're told to just leave pi. Hey, just leave it as pi. And we're good. So the answer here is 23.3 pi. So far, so good, everybody. So far, feeling nice and easy. Right on. Yesterday, we were lamenting this at first. So I'm glad to see that this is a good baseline to start off with. All right. So let's go ahead and give you a chance to try this next one out. So let's go ahead and get this going here. All right. So let's move forward here to, not an easy example, but something that's, still going to help us think about this. So first things first, what do we want? What we want is right here. Find its radius. Okay, sounds good. And I think we all know that radius is a term that is specific to circles, so we can assume that we're dealing with a circle, and it's confirmed right there. So we want to find the radius, and this is how you're going to handle word problems, everybody. So if you're confused about word problems or nervous about them, here's a nice little hint. So we want to find the radius, so I'm going to write that down. Like, that's my goal. I'm going to have that right there to remind myself. And then I'm going to ask myself, okay, what information do I have? So as you'll see in this blue highlight, you'll see that we have the circumference of this circle as 14 pi. Okay, sounds good. So I know that my circumference equals 14 pi. Now, once I know what I want and I see what I have, the next question I'm going to ask myself is, hey, how do I connect what I want and what I have? Like, is there a formula or an idea or a relationship that connects the circumference of a circle and the radius of a circle? Everybody, is there a relationship or formula that uses both of those ideas, the circumference and the radius? And if so, what is that formula? Again, this is how you want to walk yourself through word problems. You want to ask yourself, is there something that connects that idea and that idea? And every single time, if it's a properly written question, the answer is yes. So here, we know what that formula is. It is the circumference equals 2 times pi times r. And so what we'll do is we're going to fill in the information we have. Notice that we are looking for the radius, so I'm going to leave that as is. What I will do is I'm going to replace the circumference with 14 pi. Once I do that, check this out. We have 14 pi equals 2 pi r. Now that we're here, we are again solving for r. We are solving for r. So if we're solving for r, we need to get rid of everything around it. If we knew what r was, we would multiply by pi and by 2. But I don't know what r is, so I got to get rid of everything around it. And what I'll do, you can do this in one shot. You can divide by 2 on both sides. But to get this done in one shot, I'm going to divide both sides by 2 pi. Because again, we're multiplying by 2 pi, so you can just divide by 2 pi. Here's the advantage that this gives you. You do it in one step instead of 2, because guess what? If I'm multiplying and dividing by 2 pi, hey, that's gone. And then as well on the left side, if I have a pi up top and a pi on the bottom, boom, cancels out. And all we have to figure out, or just remind ourselves of, is what is 14 divided by 2. And 14 divided by 2, that's going to be 7. It's not going to be 7 pi, because right over here, these pi's, they canceled out. Again, when you have the same thing on the top and the bottom, they cancel out. So the radius is just going to be 7, not 7 pi. All right, just really wanted to clarify that to make sure that we're all good. So with that, again, you always want to ask yourself, hey, is there anything that I'm not sure of? Is there anything that I'm tripping over? That way you can keep that in mind as you continue practicing. So without further ado, let's keep it going. Let's keep practicing. But we are going to do this in the sense of learning how to accomplish this. Everybody, before I even present your notes, before I even go back and show you what this is even all about, if I were to say, everybody, hey, calculate this distance, just that right there in red, let me use a different color. If I wanted to calculate that distance right there, not the entire circumference, but just this partial circumference, does anybody here feel like they would know what to do? Does anybody here feel like they know exactly how to get this done? Yeah, and as expected, the majority of us are going to say no. And that's completely okay. Let's go ahead here and go back and take some notes. I got y'all. So let's bring it back right over here and begin with the definitions for arcs and sectors. Excuse me here, it looks like I wrote sections. I'm going to go ahead and write sector as well. Let's just correct that right there, no problem. Sector is the proper term, but sometimes you might see it called a section or a wedge, but sector really is the proper term. So let's go ahead and get into it here, everybody. So we have two terms that we already know of, circumference and area. Let me go ahead and write circumference over here. Let me use blue. And then let's go ahead and write area down here. All right. So here's how I want y'all to relate this. And don't worry, I'll give you plenty of time to write this down. But here's how I would relate this. The arc length, so the length of an arc, quote unquote, all an arc is going around the circle, but not all the way. So instead of going all the way around the circle to create the circumference, the partial circumference, so the partial rotation or partial lap, so from here to here, that partial distance, we call that an arc. That is an arc length, everybody. The full measure, that would be the circumference if we went all the way around. But we're not going all the way around, and so we will call it the arc. So everybody, quick question before we get into sectors. If we were to say, hey, the arc that I want you to calculate is from one end to the opposite end, so halfway. What would I do to calculate the length of the arc when I have the circumference? What do I do to the circumference once I have it? If I'm told that the arc only goes halfway across the circle, what would I do? Yeah, exactly. We would divide it by 2. Exactly. If we're only going halfway, then we'll take half of it. Everybody, another question. What if we said that this arc, this one that we're actually looking at, is, let's say, 1/3 of the circumference? What do I do to the circumference to find that arc length? What would I do once I had it? If I said it's 1/3 of the way. Yeah, we could definitely multiply by 1/3, or you could divide by 3. Both of those mean the same exact thing. And yeah, that's exactly what you would do. Now, if we were to take a look at this over here, similarly, as a very similar idea, when we're talking about sectors, sectors are basically partial areas. So a portion of the area. If our sector is, let's say, 1/3 of the circle, then you just take your area and divide it by 3 or multiply it by 1/3. Either way is fine. But this is the idea that I want us to understand before I let you write this down and before we get into everything else. What I want you to understand, again, is that arc is just part of the circumference. Sector is just a portion or a part of the area. That's it. How we actually calculate it is going to depend on the angles that we are given. So here, this would be 120 degrees, just like we see down here. And I'll zoom in for us so we can really see it. The degrees are going to help us figure out or realize what we're supposed to divide or multiply by. Quick question, everybody. When you think about the angle within a circle, if I were to go all the way around a circle, how many degrees is that again? Who remembers? Yeah, 360 degrees. If we go all the way around and make, about face twice, that is 360 degrees. So my proposition here is, if you don't know fractions, if you're not comfortable with fractions, this is a really good excuse to be comfortable with fractions. Here's why. Everybody, I told you earlier that if we had 120 degrees, that 120 degrees equals 1/3. That's what you would do. You would divide by 3 or multiply by 1/3, whatever makes you comfortable. But some of us may be asking, Coach, how the heck do I come to that conclusion? How do I just say, hey, 120 degrees is 1/3? Why am I allowed to say that? Well, let me show you. Everybody, one more time. A circle is how many degrees? What is the total degree measure of a circle? 360. Perfect. Thank you. So let's go ahead and divide this. And remember, division is just like saying out of. Let me go ahead and do 120 out of 360 degrees. Everyone, what is that S word that I'm about to perform on this fraction? What is the S word that we can perform on fraction? Simplifications. Exactly. So let's go ahead and say equals, and I'm going to write simplify, because everybody, guess what? How many times does 120 go into 360? 3 times. Exactly. Watch this. I can divide by 120 on the top and the bottom. And that is going to give us 120 divided by 120. That's 1. 360 divided by 120. That is 3. So that's how we get there. That's how we get to the conclusion that if they say, hey, find the length of this arc, well, all you're going to have to do is find the circumference. And since this is 120 degrees, all you got to do is divide by 3. If they gave you 180 degrees, pop quiz. If this happened to be 180 degrees, what would you be dividing the circumference by? If it was 180 degrees out of 360. Yeah, that's exactly half. 180 is half of 360. So you would multiply by 1/2 or divide by 2. So who here is starting to realize that there might be a pattern to this? That there might be a pattern to the degrees that you're given? Oh yeah, there absolutely is a pattern. And that's what I'm going to be showing you here in the next page, where the different angles that they might give you translate to very common fractions that we know. And I'm going to let you write this down momentarily. I got you. You can use these in your notes, but remember everybody, when in doubt, if you might have forgotten any of these, especially on the test, if you're not allowed to use a formula sheet, they could say, hey, here's 60 degrees. All you got to do is take the 60 over 360 because you want to see the degree measurement out of the whole circle. And so once you do that, we can calculate and say, hey, look, 60 and 360 are both divisible by 60. I'm going to simplify. 60 divided by 60, that's 1. 360 divided by 60, that is 6. And so 60 degrees is 1/6, or divide by 6. And that's right there. So even if you forget or don't memorize this entire thing, I promise you, every single one of us here can create every single entry on this list if you just divide the angle by 360. Does that make sense, my party people? Does that make sense? Excellent. So now let's go ahead and bring it back over here to the first page. I will give you the time necessary to take your notes. We'll go to the next page. We'll give you the necessary time to type in or write in your notes. And then we're getting started with example problems for arcs and sectors. All right, and here's page number 2. So with your common angle conversions. And what I'm going to do right now is I'm going to take this 150 degrees and I'm going to show you that, again, even if you completely forget about this list of common conversions, let's say you're nervous in the middle of practice and you're like, oh man, oh crap, I don't know what to do. I gotcha. Watch. I'm going to take the 150 degrees and I'm going to write it out of the entire circle. The whole circle is 360 degrees. Remember, my party people, that the phrase out of is a fraction. It's division. 150 over 360. So when you're only calculating for 150 degrees and not the entire circle, this is going to help you find out what that fraction is. And so here we go. The first thing I'm going to eliminate is the 0 on the end. Because remember, everybody, if the zeros are on the end of both the top and the bottom are both divisible by 10. That's what that means. That's what crossing out that last 0 is. So now we have 15 over 36 instead of 150 over 360. So up next, let's ask ourselves, everybody, what number goes into both 15 and 36? What number can you think of that goes into both 15 and 36? And if you're thinking the number 3, then you're correct. And watch what happens once we do that. I'll divide the top and the bottom by 3. 15 divided by 3, that's going to give us 5. And then 36 divided by 3, that's going to give us 12. And there you go. If you are dealing with an arc or a sector that is only 150 degrees, so not the entire circle, then the fraction you would use, with whatever you're dealing with, the circumference or area, the fraction that you would multiply by would be 5 over 12. Because again, 150 degrees is 5/12 of a circle. In the same way that 180 is half of the circle. In the same way that 90 degrees is a quarter of the circle. 270 is 3/4. These are all portions of a complete circle. That's all it is. Translating the angle measurement to its proper portion. My party people, does that make sense to you personally? Again, just that transition from angles to parts of the whole circle. That's really what this encompasses. You can calculate every single one of these by hand, but I'm just giving this to you as a courtesy so we can use these in today's class. Excellent. So with that, everybody, let's turn our attention over to the first example where we are going to be dealing with an arc. And this is something that we went through earlier, where I presented the issue, but now we're actually going to solve it. So here what we're trying to do is we're trying to find the measure of this arc length, quote unquote. So that's right over here. So let me get rid of what's actually annotated. Again, all we care about is the distance from this point to this point. That's all we care about. Everybody, quick question. When we're dealing with arc length, are we dealing with it as a part of the circumference or part of the area? What is arc length part of? The circumference or the area? Yeah, it's part of the circumference. So just remind yourself right over here that arc length is, again, partial circumference, partial circumference. And so here's what we're going to do. Watch and learn. I got your back here. What we're going to do is we're going to realize that, again, we're dealing with part of the circumference. And so my question is, well, what part of the circumference am I dealing with? How much of the circumference? And to find that, you need to translate the 45 degrees, this right here. You got to translate the 45 degrees. You want to know how much out of the whole circle this is. So I can go ahead and just do this. And so again, my goal is to see how much this is out of the whole thing. And watch how we're going to do that. I am simply going to divide by 360. I'm going to see how much it is out of the whole thing. And so when we do this, I'm going to start by dividing by 9 on the top and the bottom. Because 45 and 360 are both divisible by 9, 45 divided by 9 is going to be 5. And then 360 divided by 9, that's going to be 40. Everybody, are we done simplifying? Is that all we can do? Correct. That is not all we can do. We can continue simplifying. And so what I'll do next is I'll divide the numerator and the denominator by 5. Because 5 and 40 are both divisible by 5. And you'll see that 5 divided by 5 is 1. 40 divided by 5 is 8. And there we are. We are dealing with 1/8 of the circumference. That's what the 45 degrees translates to, everybody. That's what it translates to. And so we can say confidently that 45 degrees is 1/8 of the circumference. And you'll see that it's listed right over here. 45 degrees, that is 1/8 of the circle. My party people, are you seeing that this is making a little more sense? We can save a little bit of time. Instead of calculating it every single time, we can use these fractions that we have here. Yeah, it's just going to save us a lot of time. So when we come back, all we have to do now is find the circumference and then take 1/8 of it, and we are good. Given that we have the radius, my circumference is going to equal 2 times pi times the radius, which is 14. 2 times 14, that's going to give us 28. So my circumference is 28 pi. So I'm going to write this down again. This is 1/8 of the circumference. So 1/8 of 28 pi. One more time, everybody. The word of. What does that mean in mathematics? Not out of. Out of is division. The word of by itself, yeah, that's multiplication. And if you're asking, hey, where'd that 28 pi come from? Again, that's the circumference. The circumference is 2 times pi times the radius. Again, I'm using this version because we're given the radius. So 2 times pi times 14. 2 times 14 is 28 pi. So we'll replace that circumference with that 28 pi, and we just do the math. 1/8 of 28 pi can be written as 28 pi over 8. My party people, when we try to simplify this, 28 and 8 are both divisible by what? Yeah, they're both divisible by 2, but they're also both divisible by 4. 4 is going to be the better number to go with. It's the bigger number, so it will be the better one to get the simplest final answer. So let me zoom on in over here. So what I'm going to do is I'm going to simplify by dividing by 4 on the numerator and 4 on that denominator. And once we do that, we're going to end up with 7 pi over 2. So you can keep it as is, 7 pi over 2, or if you want to write it as a decimal, 7 divided by 2, feel free. But here's the big picture. The big picture, regardless of what you calculate, you need to understand why you're calculating to begin with. And so if you're asking, Coach, we're trying to find the arc length, why do I need circumference? Because remember, an arc length is a fraction of the circumference. So if you know the whole circumference and you know what fraction 45 degrees is, then you just do the fraction of the circumference. 45 degrees is 1/8. So all you got to do is find that circumference, which we did, and then multiply 1/8 times 28 pi. And this is the part that I know we'll get used to after some time and some practice, but this is the idea that we have to wrap our heads around. If we're calculating arc, it is a fraction of the circumference. Again, a fraction of the circumference. And the biggest test is just going to be, first, understanding what fraction the angle is. So 45 is 1/8. And then doing your calculation for the circumference. And then doing one more calculation after that. So before I continue, even though I will agree that this might be a little tough, a little challenging, can we agree that it is doable? Right on, everybody. Remember, we're not always looking for the easy way out. We're not always wishing things are easy. We just want to wish that things are doable. That's all we need. If it's doable, we can get it done. So let's take a look here at another example to find arc length. Yeah, so we're going to find circumference again specifically for arc length. That is correct. So let's take a look at this next example, everybody. First things first, everybody. What are we trying to find here? What are we trying to find, and what angle are we given? Yeah, we're trying to find that arc length. That's what it says. Boom, right there, arc length. And the angle that we're given, everybody, is what angle? Yeah, 225 degrees. So with that said, everybody, here's that circle. We are trying to find the arc length. So this red highlighted edge, we're trying to find that distance. Quick question, everybody. What would it be if I'm trying to find the entire distance? Not just this red, but if I wanted to complete the circle. What's that word that I would be looking for? Yeah, circumference. That's right. So notice, everybody, we're not trying to calculate the entire circumference. We're only trying to calculate part of the circumference. Not the entire 360 degrees, but just 225 degrees. Again, that's the portion, 225 out of 360. Can anybody tell me first what 225 out of 360 translates to? Who has their notes? What's that going to translate to? Yes, if you take a look at your notes, that's going to tell you 5/8. 5/8 of the circumference. So everybody, before we can fully calculate that arc length, what must we calculate first? What's the next thing on our list to calculate to be able to get that arc length? The one thing that's in our way to get the arc length is what? It is not radius or diameter. I mean, I see diameter right here. We don't need to know it if we already know it, right? What is it that we first need to calculate? It's something that hasn't been replaced yet. What has not been calculated yet? Yeah, the circumference. We haven't calculated the actual circumference yet. We have to calculate the entire thing first. Let me go ahead and do it like that. I think that's pretty cool. So I got to calculate the entire thing and then take a fraction of that. Because think about it like this. If the circumference was 8, 5/8 of that would just be 5. That's all it is. I know it seems a little difficult when we're dealing with large fractions and simplification and geometry all at the same time, but I promise you, give it some time, you can do this. So let's get it done. We want to calculate circumference. Pop quiz. Type the formula that we should use for this problem's circumference. Which formula should we use? There are two. Which one will we use? Correct. That's going to be circumference equals pi times diameter. And that's only going to be because we are given the diameter. Given that we have the diameter, I will say circumference equals pi times the diameter. Again, you want to use the proper formula for the proper situation. Circumference with diameter, that's the one we'll use. So with that, we'll plug in the diameter being 20. So we have pi times 20, which is the same thing as saying 20 pi. So quickly, everybody, what are we going to replace the circumference with? We are going to replace the circumference, not just with 20, but with, 20 pi. That's right. So I'm going to just copy this right over here, duplicate it. And so instead of saying circumference, I'm going to replace it with what the circumference actually is, which is going to be 20 pi. And the way that we write that is simply going to be 5/8 times 20 pi, which translates to the number on the top multiplies with that number by itself. Everybody, what's 5 times 20? Yeah, that's going to be 100. So that ends up being, let me change this back to black. So that's going to be 100 pi, because again, we multiplied these two together, divided by 8. And from here, everybody, we can either simplify or just do straight up long division. Whichever way you'd like to do it is whatever way it'll work for me. What you will receive once you simplify is you might notice that 108 are both divisible by 4. If we divide both by 4, we end up getting 25 pi over 2. That's what you would get. Or if you divided by the extra 2, if you did 100 divided by 8 fully, you would end up getting 12.5 pi. Both of these work. Both of these work, and it really depends on the multiple choice answers. It'll depend on if they write it as a decimal or if they keep it as a fraction. It really just depends. So with that, I see an answer in the chat box saying, hey, I got something different. And that might have been because we did 5 over 8 swapped to 8 over 5. If you did 360 on the top and 225 on the bottom, you would get 8 on top and 5 on bottom. And that might have gotten you something entirely different. And so one more time to answer that last question. I got you, Heaven. So the last question here was, how did we get the 12.5? That's if we just stopped caring about writing it as a simplified fraction. And if we just wanted to write it as a decimal, 25 divided by 2. If you go ahead and check this out on the right side, 2 going into 25 is going to give you 2 goes into 2 once, 2 goes into 5 twice. You got 1 left. Bring that decimal over. 2 goes into 10 5 times. And that's how the 12.5 comes into play. So Heaven, let me know if that makes a little more sense. Again, the general idea was you can write it as a simplified fraction or you can write it as a decimal. It really just depends on what the requirements are for that specific problem. Yeah, I got you. Again, no problem. You guys are here to learn. This is a somewhat relatively challenging topic. I am not going to shy away from answering every single one of your questions. So with that, let's keep it going here. We have talked about arc lengths. Now let's go ahead and find the areas of sectors. And again, like I said, there are 2 different ways or a couple different ways we can name it. You can name it a sector, which is sometimes confused with sections, as you saw with my notes. Another one is called a wedge. This is a wedge, just like that. So a wedge and a sector, again, they're the same thing. All right, everybody, let's check it out. We're trying to find the area of the wedge, and we see the angle that we're given right over here is 120 degrees. Everybody, question, what does 120 degrees translate to? Nice, good job with those notes, everybody. 120 degrees, that translates to 1/3 of the circle. That's right. That is 1/3 of the circle. So if we're trying to find the area of this wedge, it is going to be 1/3 of what idea, everybody? 1/3 of the circumference or area? Which one is it again? What are we dealing with here? Yeah, that's 1/3 of the area. 1/3 of the area. That's what this is going to be. We'll find the area, we'll take 1/3 of it, and we're done. And one thing that you all might have noticed, and it's probably a question that you might have, is, hey, coach, when do we leave pi as pi, and when do we use 3.14? If they specifically instruct you to use 3.14, or you don't see pi in the answer choices, then you will use 3.14. But typically, leaving pi as pi is absolutely okay. So let's go ahead and do that here. Let's figure out what this area is so we can plug it right back in. So area is only one formula for it, and it's going to be pi times the radius squared. Everybody, what am I plugging in for the radius? Pi times, 9 squared, exactly. And as a gentle, nice reminder, when you square a number, you are taking that number and multiplying it by itself. So that's going to end up being 9 times 9. 9 times 9 is 81. So you can write it as pi times 81 or 81 pi. That is the area of the circle. But that's not our answer. Let me write this down here. We're doing 1/3 of the area, which is 1/3 of 81 pi. That's what we have. 1/3 of 81 pi, which is also going to be written as 81 pi divided by 3. And now all we got to do is just simplify that right there. And we can do that. We can do that by doing 3 going into 81. Let's see what that'll be. 3 goes into 8 is 2. 2 times 3 is 6. And we get 2 left over. Drop that 1. 3 goes into 21. 7 whole times. And there we go. 81 divided by 3, when we divide by 3 on the top and the bottom, we get 27 pi. And there's our correct answer. That would be the area of this wedge that we see, or the area of this sector, 27 pi, and we're all good. That's how we would get it through and through. So how are we feeling about this one? Do we feel like, okay, this idea seemed crazy at first, but Lord behold, this is actually doable? Good. I'm glad that a lot of us are feeling that way, but this is not to discount anybody who feels like they're still struggling. Remember that we have to start with understanding the general idea before we feel confident about any of the math that we're going to see on the screen. All right? So give it some time. Give it some time. I promise you, with more practice, we'll continue to build that confidence up the right way. So I think I saw one more question before I continue about, hey, how do we get 1/3 here, from 120? Remember that what we are doing is out of the whole circle, which a whole circle is 360 degrees. 120 over 360 simplifies when you divide by 120 on the top and the bottom. If you divide by that, you will get 1/3 as the simplified version. So with that, I want to give us one more example here, right there. And once we do this example, then we're going to introduce ourselves to those word problems. And that's what we're going to focus on today. So, yep, one more time, I gotcha. So arc is part of the circumference, and a sector is part of the area. That is correct. Always, always, always. All right, everybody. So let's get it going here. Let's talk about this wedges area. Let me show you the number one mistake that a lot of people are going to make, especially in today's class, when it comes to being excited about a new idea and thinking that you can take over the world. So let's go ahead and go through this. First question, everybody, let's use our notes. What does 300 degrees translate to? What fraction of the whole circle is that? 300 degrees translates to, 5 out of 6. 5/6 of a circle. All right, cool. And again, you can easily calculate that by doing 300 divided by 360. Divide the top and the bottom by 60, and you'll get 5 over 6. Here's the common mistake that a lot of people make. They will say, hey, 5/6 of the area, because we're dealing with a wedges area. So we're going to do 5/6 of the complete area. And then you get excited. You come over here and you say area equals pi r squared. Absolutely correct. Then you might even go pi times 18 squared. Everybody, am I still good? Am I still correct? No, absolutely not. This is wrong. This is absolutely wrong. Can somebody tell me, what does r stand for? What does r stand for? Radius. That's right. R stands for radius. Everybody, is this radius? No, what was that? That was what? That was diameter. That was diameter. This is wrong. This is wrong. We should not have plugged in the 18. One more time. The r is the radius. The 18 that we were given, that was the diameter. So we always want to pay attention here. We always want to make sure that, again, whatever we're supposed to plug into the formula is actually what we have. So everybody, quick question. If we are given the diameter as 18, again, the diameter being all the way across, if all the way across is 18, what's the radius going to be? That's just halfway through, right? And given that it's just halfway through, let me change the style so we take out the filler. Okay, let me see if I can get this in the background here. Perfect. Okay, so what I'm going to do is I'm only going to show us halfway. Halfway is what we care about. Halfway is 9. The radius equals 9. Remember your relationships. The radius is half of the diameter. The diameter is all the way through. The radius is just half. And so because of that, now that we have the right radius, we can get rid of all of this and plug in the right radius, which is going to be 9. 9 squared is 81, so our area will be 81 pi. There's my area. Now we're good to go, because 5/6 of the area translates to 5/6 of 81 pi. which turns into 5 over 6 times 81 pi. And from here, this is where the math happens. We can go ahead and do 5 times 81, and then put the pi, and then divide it all by 6. You can absolutely do that. You can absolutely do that. And so we will. Everybody, what is 5 multiplied by 81? 81 times 5, 405. That's correct. Some mental math. 80 times 5 is 400. 1 times 5 is 5. 405. We can go ahead and continue. 1 times 5. 8 times 5. There you go. So we have 405 pi, but we're still dividing by that 6. So now we have to figure out what 405 pi divided by 6 is going to be. And we can go ahead and do that. Let's just go ahead and do it let's just go ahead and do long division, whatever. And we'll write it as a decimal, no problem. So here's 6 going into 405. 6 goes into 40, 6 times, minus 36, with 4 remaining. We'll drop the 5. 6 goes into 45. That'll be 7 times. We will subtract 42 because 6 times 7 is 42, giving us 3 left over. I'll continue on by dropping a 0. And now 6 goes into 30. That'll be 5 times. And so we'll write that after the decimal place. So we have 67.5 pi. And there's our answer. 67.5 pi. There we go. That is the area of this sector here. That is the area of all of that right there. Booyah. So my party people, officially here. How are we feeling? How are we feeling? Do you see the idea coming together even a little bit better, a little bit more than it has been so far? Let's try out our first word problem of this class. So here's what we have. First things first, as always, we want to read the question first. We want to know what the goal of this problem is every time without fail. So when we go through, there's my question sentence. That's where I want to start reading. So it says, how many feet of edging does she need? And we're going to leave pi as pi. Okay, sounds good. Everybody, when we talk about the edging that we need, how many feet of edge do we need here? We might need a little more information. We might need to read this a little more to understand what's going on. Yeah, sure, we have this picture here, but what does it really mean? So let's take our attention over here and let's start reading through. So a gardener frames a 180-degree sector of a circular flower bed, and the radius of this flower bed is 8 feet. So I'll go ahead and highlight that radius because that's probably going to be important. And I'm also going to highlight the 180-degree sector. Everybody, quick question. Who knows off the top of their head, what is 180 degrees? What is 180 degrees? What does that translate to in your head as a fraction? Oh yeah, you guys are good. That is, again, half. 180 degrees is half. Let me write this down over here. 180 degrees equals half of the circle. All right, cool. So if we recognize that from the jump, that's already a great place to be in. So when we read this entirely, we want to know what this edging is, which is 180 degrees, which is going to be half of the circle, half of its circumference. But you want to pay very close attention, everybody. I'm going to split this into 2 different colors. Let me first split this into, let me grab a purple and let's do red as well. So let me just erase these 2 things and let me do purple and red. All right, so here we go. She needs edging that runs all the way around the wedge. What does that mean? Pay very close attention. In red, along the curved arc. So that's this right here. Along the curved arc. And then there's a key word here. Plus. Everybody, what does the word plus mean? Just wondering. Yeah, the word plus means add. And then it says we're adding the straight line through the center. Whoa, we recognize that, everybody. What does that mean? What does straight line through the center mean? What does that mean? Yeah, that's diameter. That's diameter. So everybody, isn't it true then? Isn't it true that what we are looking for is first this part here, which is the 180-degree arc, and we're adding on top of that the diameter, because that's the straight line through the center. Is that what we're going for here? Is that what we are representing here? Again, the distance around the edge of this wedge, which is again the distance along the curve right there, and then plus the straight line through the center. So, wow, I don't care if we know how to do the math or not. When it comes to reading and paying attention to the context, to the story, I think we can all agree, at least now that we see it, for the second time, that we are dealing with the diameter plus the arc. One more time, do we agree with that sentiment? We are doing the diameter plus the arc. Perfect. So now we're going to get into the actual math. Let's get into the actual math. So let me split this up here, move the diameter over to the side a little bit. Let's find that arc first. Let's do this part first. We already said it. The 180 degrees is half of the circumference. Half of the circumference. Let's find out what that circumference is. Given the radius, let's just go ahead and use the formula that uses the radius. The circumference formula that uses the radius is going to be right over here. Let me write this in, what color did I use earlier? That's going to be red. Okay, cool. So let me just use 2 pi r. Circumference equals 2 pi r. So I'll include 2 times pi times that radius. What was that radius again, everybody? Yep, that radius was 8. So we are dealing with half of whatever that is. 2 times 8 is going to be 16. So we're dealing with half of 16 pi. Everybody, if I'm doing half of 16 pi, what does that turn back into? Yeah, that's going to turn right back into 8. That's going to turn right back into 8. So that'll be 8 pi. So let me highlight this in red. The 180 degree arc is 8 pi. Is that what most of us here got when we calculated that specific arc? Good. Now, this is the part that I just remind you gently that C is incorrect. And that's because what did we forget to bring back? What did we forget to bring back and add? Yeah, we forgot to bring back the diameter. So here's another common mistake that some folks might make. We want to bring back the diameter. Some folks might just say, okay, cool, there's 8. I see it right there. Well, be careful. Be careful. That is the radius. That is the radius. That is not the diameter. The radius is right over here, going to be the halfway point. The halfway point is 8, and the other halfway point, that's 8. That's going to give you the diameter if you do the whole thing. The diameter is going to be the 8 times 2. That is where that's going to come from, everybody. 8 times 2 is going to give us the diameter, and that's going to be 16. So our complete final answer is going to be 8 pi plus 16. Not 8 pi plus 8, because that would be just the radius. We wanted the straight line through the center all the way. So that was the diameter. So our final answer, my friends, as tough as this one was, the final answer will be 8 pi plus 16. And that will be answer choice B. And that's one. That's one knocked out of the park. How do we feel about this one, everybody? Honest opinion. Do you feel like this is becoming more doable? Right? Not terribly hard, right? Yeah, sure, it might suck. Yeah, sure, we might have some feelings about this. Might even feel a little tricky. But guess what? It doesn't feel impossible anymore. There are things that you can pick up on. And so you really want to turn, those instances of confusion into dialogue. You want to turn it into moments where you converse about this so you can, again, take the next step. So are you all ready to try out another potential problem here? Sweet, sounds good. Let's go ahead and give it another shot. So remember, the first thing you want to do, read the question sentence. Understand what you're trying to look for. Once you know that, understand the information you have, and make a plan. I do not care. I'm going to repeat myself. I do not care if you get to the part about calculating. What I care about is that you make a solid plan. That's really all I care about. We'll talk about the calculating once the timer's up. Let's get the timer on the screen and let's get it going, everybody. 3, 2, 1, problem number 2. You got this. And also, Alicia, the reason that it couldn't be D is because D was just 16, and 16 was the diameter. Remember that it was the arc length plus the diameter. So it was 16 plus the 8 pi, not just 16 by itself. That's partially correct, which would make it incorrect. All right, and we're looking at our final 3 seconds here. Go ahead, my party people, enter those answers. What do we have? What do we have? All right, right on. I see us. Okay, looks like a lot of us chose A. Got some B's and C's in there, but looks like the majority of us chose A. All right, let's see if the majority of us are correct. So here we go, my party people. First things first, when we take care of any word problem, we always want to begin by reading the question first. And the question, again, is not starting from here. No. It's the question sentence. What is the area of this slice? Area. Everybody, is there a formula for the word area when it comes to geometry? Absolutely, right? It absolutely depends on the shape that you're given. And, well, what shape are we dealing with? Well, it says, okay, area of the slice. I take a look at this slice. It almost looks like a triangle, but it is not a triangle. It's also not the entire circle. Pop quiz, everybody. What do we call this section of the circle? It is not the entire circle. We cannot call this a circle. Yeah, we can either call it a wedge or a sector. Those are two acceptable responses, a wedge or a sector. Again, this is a sector. And as a reminder, a sector is literally a fraction of a circle, a fraction of the whole thing. And it really depends on the degree measurement, the angle that you're given. That 45 degrees that we're given, that is part of the circle. It's out of the entire 360 degrees. So let's remind ourselves, 45 degrees, let's use those notes. 45 degrees translates to what? And if you didn't know, all you need to do is 45 divided by 360 because the whole circle is 360. And when you do the math, you get 1/8. 45 degrees is the same as 1/8 of a circle, 1/8 of the entire thing. So now that we know that, we can keep this right here on the side because we're going to calculate the area, but we are going to do 1/8 of the area of the circle equals the area of the sector. Again, the sector is just part of the circle. So what we're going to do now is we're going to find the area of the complete circle, multiply it by 1/8, and we're done. And that's it. So with that, here we go. Area, the formula for the area of a circle is going to be area equals pi r squared. My party people, what is the radius that we're given? Yeah, that's going to be 12. So let's go ahead and highlight that right here. Let's grab that. Radius is 12, so I'll plug that in. Let's zoom on in a little bit. Area equals pi times 12 squared. My party people, what's 12 squared going to give us? 12 times 12, 144. That's correct. Area equals 144 pi. And there we are, everybody. That's the area of the circle. That's the area of the circle. We're not done. We still need to take 1/8 of that area. So when we do that, 1/8 of 144 pi, that's going to equal 144 pi divided by 8. Now let's go ahead and see what that's going to be. Let me change colors. I'll use green here. I'll do 8 into 144. 8 doesn't go into 1, but it does go into 14, and that's going to be once. Then we subtract 8, and that's going to give us a leftover of 6. Then we drop the 4. Everybody, 8 goes into 64. That'll be, 8 times. So we have 18. 144 divided by 8 is going to give us 18. So the answer is 18 pi. And then when it comes to this being an area, everybody, is it true that the correct answer would be listed as 18 pi centimeters? Incorrect. That's right. It's going to be centimeters squared because, again, this is area. Area is a two-dimensional concept, so you need a two-dimensional unit, square centimeters. And there we are. The correct answer, my friends, is going to be A. Who here is excited about getting this question correct? Who here is excited about maybe perhaps seeing this question in the past, maybe perhaps on the test itself, and you're looking at this like, oh, buddy, if I see this again on the test, I might have a chance. You can feel those scores rise. That's right. And so common mistakes that we might see in this problem here, common mistakes are incorrect translations of the angles. 45 degrees is 1/8. If you need to do the math, you can do 45 over 360. It will simplify to 1/8. Another common mistake is stopping when you're done with the area of the whole circle. And another mistake, one of the more common ones, is mistaking the area formula with the circumference formula. That's also a common mistake that can be made. And if you want to see this for the peace of mind, I got you. 45 over 360 to translate this. You can do this, simply put, by simplifying. 45 and 360, we can start off with 9. They're both divisible by 9. And so let me just write this over here. 45 divided by 9 is 5. And 360 divided by 9 is 40. From here, the last step would be dividing the top and the bottom by 5. You can still simplify, so we will. 5 divided by 5 is 1. 40 divided by 5 is 8. And so that's how we get the 1/8. But again, if you want to memorize your angles, sure, go that route. But if you ever forget your angles, you got to trust your ability to simplify fractions to get the simplest form. Because I don't think anybody here wants to multiply 144 pi by 45 over 360. I think we could all prefer the simplified version. Shane, so that was your mistake. You just simplified incorrectly. So again, like I said before, the calculation, that's the least of your worries. I really want you to be excited more about, the process here and the understanding of the idea. We can get the literacy and the automaticity when it comes to the calculations with enough time. So with that said, everybody, are you ready for one more question? Hey, right on, my party people. Let's go ahead and get it in here. So let me get this ready and let's get to it. All right, let's handle this next one. As always, no matter what the question is, read the question sentence first. So it says, how far does the skater travel along that arc? And I think we might be talking about this over here. We see that we have our circle with an arc identified from this point to this point. And then we see that we are labeling that angle here as 60 degrees, which is also reaffirmed here in the actual information. So right over here, again, this is 60 degrees. Okay, so let's understand this fully. We want to know how far this skater traveled from here to here. We want to know what that distance is. And that is called, again, an arc. Remember that an arc, to find the length of an arc, is going to be the portion of what idea, everybody? The circumference, or is it the area? Which one is it? The arc is part of the correct circumference. It's a portion of the circumference. And to understand fully what that portion or fraction actually is, we need to understand what 60 over 360 is. Because remember, a full circle equals 360 degrees. So we want to know what portion 60 out of 360 is. My party people, what does that simplify to? What does 60 over 360 simplify to? 1 over 6, that's correct. So we have 1 over 6 of the circumference. What's that circumference going to be? Here we go. The circumference, and I'm going to just highlight this as a blue box. Hopefully that's enough space. We will find out. But we will go right over here. Because I am given the radius of 15 meters, I'm going to use the radius formula. So I'm going to say C circumference equals 2 times pi times the radius. My radius is again 15. So I have 2 times pi times 15. Everybody, what's 2 times 15 going to be? 30. That's correct. So the circumference here is going to be 30 pi. We have our circumference, and I can just tag that right down here. 1/6 of meaning multiply, 30 pi. And now that we're here, we will continue by multiplying the fraction with 30 pi, which will be 30 pi over 6 And my friends, this might be a little easier now. What's 30 divided by 6 going to give us? Yeah, it's going to be 5. 30 divided by 6, that's going to give us 5. We still bring that pi with us. But there's something a little strange here. I don't see my answer. Why is that, everybody? What am I supposed to do now, given that I don't see my exact answer, 5 pi, listed? Yeah, notice there is no pi listed in the answer choices. There's no pi listed at all. And so because of that, we must use the approximation. We must use the approximation. The approximation for pi is 3.14. And so that's what we're going to do. 5 pi is 5 times 3.14. We can do that right over here, 3.14. And really quick, if somebody is asking, hey, coach, why aren't we doing 30 times 30? It's because this is circumference, not area. Remember, if this was area, it would be 15 squared, radius squared. But this is circumference. It's 2 times the radius and times pi. So hopefully that clears that up there in the chat box. I saw that. And I know somebody watching this recording might have that question too. But let's go. 4 times 5 is 20. Carry the 2. 1 times 5 is 5. Carry the 2 is 7. And then 3 times 5 is 15. What we'll do at the end is we'll count the decimal places 1 and 2. And we'll bring that back. 1 and 2. So our final answer here will be 15.70, which is the same thing as just saying 15.7, and that'll be 15.7 meters. And there we are, my party people. And there we are. The final correct answer is answer choice D. Booyah, my party people. And that wraps things up here with our examples and our exercises that have to do with not circumference and area, but partial circumference and partial area, better known as arcs and sectors.